Lesson 9.5 is about dilations. You'll learn how to determine whether a dilation is an enlargement, a reduction, or a congruence transformation, and determine the scale factor for a given dilation. How to use dilations when you use a computer. Have you ever tried to paste an image into a word processing document and the picture was too large? Many word processing programs allow you to scale the size of the picture so you can fit it into your document. Scaling a picture is an example of a dilation. All the transformations you've studied so far in this chapter produce images that are congruent to the original figure. A dilation is another type of transformation. A dilation is a transformation that may change the size of a figure. A dilation requires a center point and a scale factor. The figures show how dilations can result in a larger figure and a smaller figure than the original. Triangle A', B', D' is a dilation of triangle ABD. And this time they took, their factor was 2, so the original length they have doubled. In the next figure, r is 1/3, which is less than 1, so it creates a reduced image, smaller than the original. If the absolute value of r is greater than 1, the dilation is an enlargement. If the absolute value of r is between 0 and 1, it's a reduction. If the absolute value of r equals 1, it is a congruence transformation. When discussing dilations, scale factor has the same meaning as with proportions. The letter r usually represents the scale factor here. As you can see in the figures, dilation preserves angle measure, betweenness of points, and collinearity, but does not preserve distance. That is, dilations produce similar figures, therefore dilation is a similarity transformation. If a dilation with center C and a scale factor of r transforms A to E, B to D, then ED equals the absolute value of r times AB. So we're going to use that theorem in example 1. They ask us to find the measure of the dilation image of CD using the given scale factor. So they had CD is 15 and r is 3. The absolute value of 3 is 3. So my new length of CD is going to be 3 times 15 is 45. We're using the same formula. This time they gave me the translated image, the dilated image of 7. And I need to take the absolute value negative 2/3, would just be plain old 2/3 times CD. To get rid of the 2/3, I'm going to multiply by its reciprocal. So I get 21 over 2 is CD. At this point, some of you are probably starting to ask, why do I need a negative r? If r is positive, we're going in the same direction when we make our dilation image. If r is less than 0, if r is negative, we're going to go the opposite way. So we're moving in the opposite direction. So not only will we be changing size, but it'll look kind of like a reflection. Okay, they ask us to draw the dilation image for trapezoid PQRS with a center of C and r equals negative 3. So this time we're going to take each of our segments QC. We need to now triple to make CQ prime. PC, we're going to triple to make CP prime, and so on. So when we connect our points, we can see that our translated image, transformed image, the blue image, is an enlargement of the original yellow one. So theorem 9.2 is not a big leap forward. If point xy is the preimage of a dilation centered at the origin with scale factor r, then the image P prime is rx, ry. If we have a trapezoid with the given vertices, they ask us to find the image after dilation center at the origin with a scale factor of 1/4, sketch the pre-image and image. Honestly, I would be fine with you just writing down the answers on this one because it's pretty straightforward. All I did was take each coordinate and multiply it by 1/4, which is the same as dividing by 4. And it is so nice doing this in color because it's easy to see. The yellow is the pre-image and the blue is the reduction, is our image. They ask us to determine the scale factor used for the dilation with center C and then determine if it is an enlargement or reduction or congruence transformation. Well, I'm using my awesome counting skills here. I count 1, 2, 3, 4, 5, 6 in the original and 1, 2 squares in the new. When we do image length, when it's scale factor, we're looking at image length, which my original image was, my pre-image was 6, was in my original, and the image length is 2, pre means before, so that's going to reduce to 1/3, which of course is a reduction because it got smaller. And this time I'm going to get the length of that side, so I'm going to do 1 squared plus 1 squared, or 2 squared, and a squared plus b squared equals c squared. So that's a square root of 5, and sure enough, down here I've got a 2 and a 1 also, so that one's also going to be square root of 5. Now, both segments have the same length. They're both square root of 5, but if we look at their slopes, the first one has a negative slope and the second one has a positive slope. So they are kind of reflected images. So actually the ratio of, just for the scale factor, is 1. But we're going to call it -1 because it's going in the opposite direction. If it were actually +1, it'd be laying on top of it. And that is an example of an isometry dilation. A dilation with a scale factor of 1 produces an image that it would exactly coincide with, lay on top of, if it were a +1. So the two images are congruent. Since this one is -1, my negative kind of got lost in my circle there, the images do not coincide. They don't lay on top of each other, but it's still an isometry because they're the same size and shape. Sharita built a frame for a photograph that's 20 centimeters by 25 centimeters. The frame measures 400 millimeters by 500 millimeters. Which scale did she use? I have no idea why they changed the units, so we need to get them both in the same unit. We know that there are 10 millimeters in a centimeter. So when we divide by 10, the metric system is brilliant. We just move our decimal one place. So I'm going to get 40 centimeters. And same thing, we're dividing by 10. So move our decimal one place to the left, and I get 50 centimeters. So my image length is 40, and the pre-image was 20. They're both centimeters. And 4 divided by 2 is my scale factor. And the same thing would be true if I did 50 over 25. I still get 2, which was choice A. In summary, dilations can be enlargements, reductions, or congruence transformations.